So good day everyone. I am Arvin Jay Emilio from BSED Math 3B, and for today, our discussion is all about the real numbers. So let's get started. So to start our discussion, let us first define what are real numbers. So real numbers can be defined as the union of both rational and irrational numbers. So further in this discussion, we will define or describe what are rational numbers and its difference from irrational numbers. So just keep listening. Another definition, they can be both positive or negative and are denoted by the symbol R. So any number that are positive or negative are considered as real numbers. Of course, it is denoted by the symbol capital R. Now let's look at this illustration. So this is the real numbers flowchart. So we can see here, real numbers are divided into two types, which are the rational numbers and the irrational numbers. And then under the rational numbers, we have the integers, the whole numbers, and the natural numbers. So further in this discussion, we will define them one by one, and let's see the difference between the rational and irrational numbers. So now let us define what are rational numbers. So rational numbers are real numbers that can be written as fractions with integers. So as we can see in this illustration, any number that we can write as a simple fraction are considered as rational numbers. Now, this is the condition. So the numerator must be an integer and the denominator must be a non-zero integer for us to consider it as a rational number. So we have three examples right here. First, we have the number 1. We know that if you convert it to fraction, 1 is equal to 1 over 1. So 1, the numerator 1 here is an integer, and the denominator 1 is a non-zero integer. Therefore, we consider 1 as a rational number. Second example, we have 0.25. We know that if you convert it into fraction, that is equal to 1/4. And the numerator 1 here is an integer. The denominator 4 is a non-zero integer. Therefore, we consider this as a rational number. Another one, we have negative 0.75. We know that in fraction, that is equal to negative 3/4. Negative 3 is also an integer, and the denominator 4 is a non-zero integer. Therefore, we can consider negative 0.75 as a rational number. So another thing that we need to consider is that rational numbers are denoted by the symbol capital Q. So now let's go to the third definition. A rational number can be expressed as a terminating or non-terminating recurring decimal. Now we have an example right here. We have 1/2. So as a decimal, 1/2 is equal to 0.5. And 0.5 is considered as a terminating decimal because 0.5 here is considered as terminating decimal because it has an end digit to the right of the decimal, and the end digit here is 5. There was no other number right here that goes infinitely. it just ends with 5. So this is an example of a terminating decimal. Another example is we have 1/6. So as a decimal, 1/6 is equal to 0.16666 and so on. So this is an example of non-terminating recurring decimal because this doesn't have an end digit. So 0.1666 goes infinitely or endlessly. And recurring decimal also because 6 keeps on repeating. It keeps on repeating infinitely. So this is an example of non-terminating recurring decimal. And 1/6 is considered as a rational number. Okay, we already know what are rational numbers. Now let us go and discuss or define what are irrational numbers. So irrational numbers are real numbers that cannot be written as a simple fraction. So we have here the famous and so familiar mathematical symbol, which is pi. This. And pi is approximately 3.14. So the difference between rational and irrational numbers is that, for example, this symbol, the pi, we can write it as a decimal. It is approximately 3.14, but we cannot write it as a simple fraction. So that is the difference between rational and irrational numbers. Irrational numbers are denoted by the symbol capital Q prime. Now let's proceed to the second definition. An irrational number has endless non-repeating digits to the right of the decimal point. So we have 3 examples right here. First, we have the pi. Pi is equal to approximately 3.14. But beyond 0.14, there are other numbers or non-repeating numbers that goes infinitely. Same to the Euler's number. It is approximately 2.71. But in reality, that is 0.71 goes beyond with non-repeating numbers endlessly. Also, square root of 2, approximately 1.41, but it goes infinitely also with non-repeating digits to the right of the decimal point. So that is an irrational number. Now we have already discussed or we have already known the difference between rational and irrational numbers. So under the rational numbers, we have the integers. So let us first define what are integers. So integers are real numbers that have no decimal. So we have an example, -1, 0, and 1. It is denoted by the symbol capital Z. So as we can see here in this number line, so from 1 to positive infinity, including 0, and then -1 to negative infinity are all or part or considered as an integer. So now let's proceed to the second definition. Integers are whole-valued positive or negative number or 0. So what it means to say is that integers doesn't have any fractional numbers or any decimal numbers. Just like these examples, we have 1 to positive infinity, 0, and then negative 1 to negative infinity, those are whole valued positive or negative number, and they are considered as an integer. They do not have any fractions or any decimals. So now, let's proceed to the whole numbers. This is also under the rational numbers. So let us define first. Whole numbers are positive real numbers that have no decimals, including 0. So for example, we have 0, 1, and 2. It is denoted by the symbol capital W. So as we can see in this number line, the only difference is that integers includes negative whole numbers or whole valued numbers, but this time whole numbers are just 0 and then 1 to positive infinity. It doesn't have any fractional numbers also, and it doesn't have any decimal numbers. Now, let's proceed to natural numbers that are also under the irrational numbers. So natural numbers are real numbers that are no decimal and bigger than 0. Example, we have 1, 2, and 3. It is denoted by the symbol capital N. As we can see in this number line, the only difference is that whole numbers include 0, but natural numbers starts with 1 to positive infinity, without any fractional number and without any decimals. Second definition, natural numbers are also called as counting numbers. Why is it so? Of course, when we try to count, we always start with 1, right? And then it goes beyond the positive infinity. So 1, 2, 3, 4, and so on. That's why it's called also a counting number. So now we have already known what are real numbers, the difference between rational and irrational numbers, and the difference between integers, whole numbers, and natural numbers. Now we are proceeding to our next topic for today, which involves integers. We are now be working with integers. So let's get started. So first, we have the addition of integers. So this is the rule. When the two numbers have the same sign, positive or negative, you will just add them and use the same sign they have. So we have two examples right here. So first example, we have 15 plus 12 is equal to 27. So let me illustrate. So 15 doesn't have any negative sign beside it, so it is understandable that 15 is positive. So positive 15 plus 12 is also positive. Positive 12. So we were to add them. So 7 and then 2. So that is equal to 27, and then their sign is positive, so we will just copy it. Positive 7 or positive 27. Let me just erase this. So second example, we have negative 14 plus negative 33. So this time they are both negative. So let me illustrate once again. So we have the sign negative here. So negative 14. Excuse my writing. Plus negative 33. So we were to add them. So 4 plus 3 is 7. 1 plus 3 is 4. And their sign is both negative, so we will just copy it. So we'll come up with the answer, negative 47. That's how the rule works. So now let's proceed to case number 2. So what if the two numbers have different sign? So this is the rule. When two numbers have different sign, positive and negative, you will subtract them and use the sign of the larger number. So we have these two examples right here. First, we have negative 12 plus 15. We will subtract the two numbers and then we get 3. Let me illustrate this. So for us to have an easy time on subtracting, we will first write the bigger or the larger number. That is 15. And then the smaller one is 12. So according to the rule, we will just subtract this. So we will disregard first their sign, and then we will just use the sign of the larger number after we subtract. So 5 minus 2 is 3. 3. And then we will use the sign of the larger number. So the larger number here is 15. Its sign is positive. So that's why we come up with an answer of positive 3. So let me erase this for you. Now let us proceed to the second example. 17 plus negative 25 is equal to negative 8. So how did that happen? We will first write the larger number, which is 25. We'll disregard their sign in solving, and we have 17. So we will minus or subtract. So 5 minus 7 can be, so we will borrow 1 from here. So 15 minus 7 is 8. Excuse me for my writing. So 1 minus 1 is 0, so we will not put it already on that one. So 8, and we will use the sign of the larger number. So the larger number is 25. Its sign is negative, so we get negative 8 as the answer. So now we're done with addition. Let us now proceed to subtraction of integers. So this is the rule. Change the operation sign to addition. Change the sign of the number following the operation, and then follow the rules of addition. So we have this example. So negative 2 minus negative 4. So according to the rule, we will change the operation sign to addition, and then change the sign of the number following the operation. So the number here following the operation is negative 4. We will change its sign to positive. And then we follow the rules of addition. So in addition, if two numbers have different sign, we will just subtract them and then follow the sign of the larger number. So here we have 4 minus 2, that is equal to 2. And then the sign of the larger number, which is 4, is positive. So we get positive 2. So now we are done with subtraction of integers. Let us now proceed to the multiplication and division of integers. For case 1, this is the rule. When two numbers have the same sign, just multiply or divide, then give the result a positive sign. Let's have first an example for multiplication. So on the first example, we have negative 8 multiplied by negative 4. They have the same sign, which is negative. So we'll just multiply. 8 multiplied by 4 is 32. And we give the result a positive sign. So that's why it is positive 32. Same with the second example, we have positive 8 multiplied by positive 4. They have the same sign, which is positive, so we will just multiply them. 8 multiplied by 4 is equal to 32. And we give 32 a positive sign. That's why we have positive 32 as the result. Another example for division. So on the first one, we have positive 27 multiplied by positive 3 or divided by positive 3. So we will just divide. 27 divided by 3 is equal to 9. Give 9 a positive sign. So this positive 9. Same to the second one. Negative 27 divided by negative 3, they have the same sign, which is negative. So we will just divide. That is also equal to 9, and 9 is positive. So that's just how easy to apply the rules in multiplication and division. And now let us proceed to case number 2. What if the two numbers have different sign? So when two numbers have different sign, multiply or divide and then give the result a negative sign. So an example for multiplication, we have here positive 8 multiplied by negative 4. They have different signs, so we will multiply them also. But we will give this time a negative sign to the result. That's why we have negative 32. Another example for division. So negative 27 divided by positive 3. We will divide them. That is equal to 9, but we will give a negative sign to the result. That's why we have negative 9. Same with this. 27 divided by negative 3, that is equal to negative 9, following the rules of multiplication and division for case number 2. So that ends our lesson for today. But before we end this discussion, let us first try to answer the following examples that I have provided, applying the rules of working with integers. So let's have number 1. Number 1, we have 23 plus negative 5. So in the rules of addition, when two numbers have different sign, we will subtract them. So we have 23 minus 5. So 13 minus 5 is equal to 8. And then bring down 1. And after that, according to the rule, we will use the sign of the larger number. So the larger number here is 23, obviously. So its sign is positive, so we give 18 a positive sign. And the answer is positive 18. Let's check if our answer is correct. So we are correct. So now let's proceed to number 2. So number 2, negative 13 minus 7 or minus negative 7. So according to the rules of subtraction, we will change the operation sign to addition. So negative 13 plus, and then we will change the sign of the number following the operation. So the number following the operation here is negative 7. So we will change its sign, so it will become positive 7. So negative 13 plus 7. Now after that, we will follow the rules of addition. So when two numbers have different sign, in addition, we will subtract them. So let's first copy the larger number for us to have an easy time to subtract. Minus 7. So the answer here is 6. And then for the sign, we will use the sign of the larger number. So the larger number is 13 and its sign is negative. So therefore, we will have negative 6 as the result. So let's check if our answer is correct. So we are correct. Now let's proceed to number 3. We have negative 3 multiplied by negative 9 multiplied by negative 2. So first, let us multiply negative 3 and negative 9. So applying the rules of multiplication of integers, when two numbers have the same sign, we will just multiply, then give the result a positive sign. So negative 9 multiplied by negative 3, that is equal to 27. Positive 27 because they have the same sign. And then positive 27 multiplied by negative 2. So in multiplication, once again, if the two numbers have different sign, we will just divide them and give the result a negative sign. So 27. So 27 multiplied by 2 to 14, carry 1. 4 carry 1. 2 times 2 is 4, plus 1 is 5, so 54. We will give the result a negative sign because they have different signs. So negative 54. Let's check if our answer is correct. And their answer is correct. So for the last one, we have the number 4, negative 12 divided by 3. So applying the rules of division, we will just divide them and then give the result a negative sign because they have different signs. So just first divide them. This is equal to 4. That is 12. And that's 0. So the answer is negative 4. So let's check if our answer is correct. And our answer is correct. So that ends our discussion for today. I hope you've learned something from what we have discussed and you've been familiarized with the real numbers and the rules of working with integers. So that's all. Thank you and God bless.